x, but that's okay. It's the same type of deal, right? So we know that functions for cosine and sine have the form a cosine of b theta x. Theta is just a variable just like x. That's my amplitude. That's the number of cycles from 0 to 2 pi. So once again, what's my amplitude? 3/4. Good. How many got that right? Awesome. Good. It was not a trick question. This is actually right off the end of level test. And then how many cycles from 0 to 2 pi? 1/2, right? B theta. Okay. How many got that right? Good. Some of you even went as far as to give me the period, which was great. So good job for you. All right. Questions on this? Any questions whatsoever? Okay, let's just get started. My goal is the same as yours, not to make you have homework. So let's just get going. Okay, so today we're doing 6-6. We're going to be translating sine and cosine. So we're going to be dealing with graphing sine and cosine, but now we're going to be translating the function. So translation means moving, right? So just recall, for all translating of all functions, we take it from the parent function and we shift it. So remember, we can take a function, we can shift it left and right, or we can shift it up and down, and it works the same for all functions. So just in general, if we have a function, f of x is our parent function, means non-shifted function, and we take something and add it in with our x, in parentheses. Isn't that our shift left and right for all functions? I know we always go the opposite of the sign. Okay? And then if anything is added on the outside of our function, not in the parentheses, it's our shift up and down, and we go with the sign. So that's going to be the same for sine and cosine as well. So we're going to be just taking periodic functions such as sine and cosine, and we're going to be shifting them left and right, and shifting them up and down. So just a couple things to note. A shift left and right is called a phase shift. And so they might just say, what's this phase shift? And you'll have to know that just means what's my shift left and right. So not really hard, but just you have to know that. So once again, shifting left and right will be added in with our parentheses, with our x, or our variable. And then our shift up and down is going to be added on the outside, and this will shift it up and down. So, just looking at these aren't periodic functions, but I'm just going to ask you, what's the phase shift on this function? Right 2, right? So, our shift left and right is called a phase shift for periodic functions. So this is right 2. Does everybody see why it's right 2, or any questions? We always go opposite of anything added in parentheses with our x. Added. Okay, what about this one? We're going, good, left, 3 pi, half, that's our phase shift. Good. So just pretty straightforward. Do 7 through 8. Wait.
7 through 8?
What? I mean, 1 through, was I thinking? 1 through 6 is what I really meant to say. I think I don't know what happened. Go. Do problems 1 through 8. Sorry. I'm remembering now. 1 through 8. Next part here. So it says, graph the translation of y is equal to cosine of x on the interval from 0 to 2 pi with this. Y is equal to cosine of x plus 2. First of all, is there parentheses trapping that in there with x? Is 2 being added with x? No. So we're literally taking our cosine function, shifting it up 2. So we're going to go ahead and graph. So it says from 0 to 2 pi. So y is equal to cosine of x. My amplitude is 1, right? And the number of cycles I'm drawing is 1, right? Well, Vx is 1x. So I'm drawing 1, -1, drawing in my amplitude. And then I'm going to draw in, first of all, the original cosine function here. So I'm going to draw it in. So cosine starts at starts at 1, swoops down and back up, right? That's 1 cosine. Yep. And that's 2 pi. Is everybody okay with that?
Yep.
Okay, so now this is what I really need you to do in graphing today. It's going to be, we're going to get into some, it's not tricky, but it's kind of hard to specify. So I do need you to graph in all stopping points. So think about as a unit circle. You know how we have 4 stopping points? Remember? Bing, bing, bing. So I want you to make sure you graph all those. So we have 2 pi, cut in half would be pi, right? So that'd be right there, right? Cutting that in half would be right there, which would be at pi halves. So there's another stopping point. So I guess there's 5 stopping points technically. And then also, so 1 pi halves, 2 pi halves, isn't this 3 pi halves? Okay, so that's how specific I want you to be. So there should be 5 stopping points. Okay, so now we're taking that and shifting it up 2. So let's shift each of those up 2 units. So we're at, right here we're at 1, right? Right, everybody?
Yep.
So we're going to be going up 1, 2. So that becomes there. This we're at 0, going up 2 units. And see, I didn't draw this very good, drawn to scale, because I went clear up to here 1 unit, you know. And then I made this really, so I'm going to actually fix that before I get.
So do you want us to grab that and the new one?
Yeah, it makes it way easier. So this was 1, so 2. I'm making it a little bit more drawn to scale here. So 1, 2, 3. Okay. So now I'll do it. So I'm shifting this point up 1, 2 units. It's now there. I'm shifting this up 1, 2 units. It's now there. This is right here. So we're going up 1, 2. It's now there. I'm going up 2 units. 1, 2. It's now at 2. And then I'm going up 2 units. It's going to be up at 3. So do you see how I took my cosine function, ding, ding, shifted it up 2 units? Yep. So it really just makes it way easier to draw it in the original function and then the shift, and that's what I'm going to have us do. Okay. Another one, it says, graph the translation of y is equal to cosine of x on the interval from 0 to 2 pi, but now we're shifting it right 3, right? So right 3. Yeah. So we always go opposites, add it in with x, so we'll draw it in again. So our amplitude for this was 1, and number of cycles we're drawing in is 1. So 1, -1. I'm going to draw in 1 cosine, so starting up here, droop down and back up. So we have a 2 pi, halfway through is pi. I like drawing my dots really big so I can see where I'm going. I'm not drawing this very to scale. 3 pi halves. Okay, so now write 3 units. We'll be shifting 3 units. So the tricky thing is, what's 3 units is the tricky thing.
Wow. But I'm asking myself too.
So what I would do, well, and it depends on how technical we want to get here. So pi halves, right? Let's write it as a decimal. What is pi halves? Decimal wise. So help me out so it's way quicker.
1.14.
It is 1.1. Okay. And then what's pi? 3.14, right?
Yeah.
And then what's 3 pi halves? I did not draw this through scale. I should say 2 pi's a little bit more over there. It's, sorry, what was it? What's 3 pi halves? 4.7, and then what's half? 2 pi.
6.14.
6.2? Okay, awesome. So 3 units, if we wanted to get technical, we're at 1.1. So we're going 3 units, so like 1, so we'll be, it depends on how technical. We're going to get technical later. But 1.1 plus 3 is 3.1, right?
Yeah.
So we'll be at 4.1. Oh, I should have started with 0. So 0 plus 3 is 3. So we were at 0, we're now at 3. Wouldn't that be about, this is 3.14, wouldn't that be about right there?
Yeah.
You see how you have to kind of think about these ones? And then 1.1, that's where we were at pi halves, and we're adding 3, so 4.1. So that would be about, oh, we're supposed to be going right. And I'm going right, right?
Right. Sure.
Right. If left would be this way, right?
Yeah.
So then going so we're going to 4.1 would be about right there. And then right here going 3.14 plus 3, you'll be at 6.14, right? So this will be at about 6.14, and then once again 4.7 plus 3. Do you see what you're doing, the gist? And like, so I don't need to keep going, but this is going to end up looking like this, shifted right 2 units. So you can just add it. I like to use the physical number for this one. Made it easier for me. Okay. I don't need you to be perfectly perfect for these. So let's just quickly, these ones are the easiest. It says describe the phase shift and vertical shift. So looking at it, we know my amplitude is 2, right? Can you like face me so I know you're like listening? Thank you. And where's my shift left and right?
No, wait. Left and right is right and high.
We're going right pi.
Oh, wait, no.
And then are we shifting up and down at all? Nope. So our phase shift is right pi, right? No shift up and down. What about this one? Our phase shift is left 2, and then we're shifting up 7. Okay, do 9 through 14. Okay, so now we're just going to graph some shifted cosine and sine functions. There's going to be a couple of things I'm going to help you make these easier on yourself because I need them to be decently accurate. So follow what I say, but give yourself plenty of room. I had to redo all of them because I'm like, oh my gosh, this is just confusing because it was all squished. So here's my first example. We're going to graph this function on an interval from 0 to 2 pi. So first of all, I go through and find my amplitude. What's my amplitude? Remember amplitude was multiplied in front of cosine, right? So my amplitude is 1. Does everybody see how the amplitude's 1?
Yeah.
Okay. Now the next thing I look at is the number of cycles from 0 to 2 pi. Now remember, that's what's multiplied in front of the x. So do you see we have a 2 multiplied in front?
Yeah.
Okay, so we're going to have 2 cycles from 0 to 2 pi. From 0 to 2 pi. And then we are shifting left pi halves and down 2. Does everybody see how now I'm writing out my shifts? So left pi halves and down 2. Okay, so now that I have all that, I can go ahead and start. So a couple of things that I'm going to be switching colors, and if you need to borrow some colors, there just gets a lot going on. So I'm going to first of all go ahead and draw in my amplitude. So I'm going to draw in an original cosine function and then shift it. It's way hard otherwise. So we have an amplitude of 1. So 1 and negative 1. I'm going to draw that in. As straight as your lines can go, it gets really confusing with so much going on in a second. So the prettier you draw your picture, the easier you are making it on yourself. Okay, so now I'm going to go ahead and draw in, it's a cosine, and we're drawing in 2 cycles from 0 to 2 pi. So originally, the non-shifted one would be, there's 1 cosine, right? Everybody?
Yep.
And then 2 cycles. There's 1 cycle, there's 2. So that's from 0 to 2 pi, so I know that this is 2 pi. So then cutting it in half, wasn't this pi? Everybody following me?
Yeah.
Okay, now remember, we have a couple of stopping points. We have this one and this one in one cycle. We have this stopping point, right? This stopping point and this stopping point. So halfway would have been pi halves, right? And then this would be, okay, so pi fourths, right? And then, so this is 1 pi fourths, 2 pi fourths, isn't this 3 pi fourths? And this is 4 pi fourths, right here will be 5 pi fourths. And this will be 6 pi fourths, right? Which is 2 pi. 6 pi fourths is 3 pi halves, right? So I'm going to write that 3 pi halves. Yeah, because that's a hideous 3 pi halves. And then we have this stopping point, so that was 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths. Isn't it 7 pi fourths? And then 8 pi fourths, which is 2 pi. So I draw my dots really big because we're going to be shifting the dots. Is everybody comfortable up to here? Because it gets confusing, even for me. I get like, oh. Okay, so now we're shifting all of these left pi halves and down 2. I'm just going to take care of the down 2 for right now. Well, actually, we'll do that in a second. Let's go left pi halves. Now, here's how I like to do it. So we're going left pi halves, so we're shifting back pi halves, right? So I'm going to go ahead and say I have a bunch of stopping points. I'm going to just do a couple like this. So we're at 0, right? Right here, isn't this 0?
Yeah.
And then we're subtracting pi halves, right? Everybody, isn't that shifting it back pi halves? Wouldn't we, if we subtract pi halves, be shifting it back pi halves?
Yes.
So we're going to be at negative pi halves. Does everybody understand how we started at 0 at this point and we're going to shift it back to negative pi halves? Okay, I'm going to write that in. Okay. Because that's not all we're going to do. We'll do this all at once. Now, another stopping point was pi fourths. So pi fourths minus pi halves is go. So calculators. So you'll do it. You can't type in pi in your calculator. Type in 1/4 minus 1/2. Oh wait, yeah, we're subtracting pi halves, right?
Yeah, we are.
Well, where did I mess up?
No,
Then?
because it's x plus pi halves.
No, it says less pi halves, so we should be subtracting. Where did I mess up then? Okay, there we go. Negative pi fourths, right? So it's negative 1/4. So that's at negative pi fourths. And then we have another stopping point at pi halves, right? So we're doing pi halves minus, we're shifting that back, pi halves. So pi halves minus pi halves is 0. And then we have 3 pi fourths. And then we're subtracting pi halves. So this is just so you can see where you're landing. Does that make sense, everybody?
Yep.
Okay, so 3 halves minus 1/2 is 2 halves, right? Which is, hey, you people over there going crazy. No, you're going crazy. Okay, pi. Okay, so just so that we can see what's going on. So do you guys see how I have these points? So now I'm going to shift all of those back we're going to shift it from 0 back to negative pi halves, and then we're going to also go down 2. So I'm going to also draw in another asymptote, or you might not need to. Kind of depends on who you are. So I personally want to draw in a new asymptote. So if we were at 1 and we shift down 2, won't this be our new asymptote on top? And if we're at negative 1 and we're shifting it down 2, so this will be our new asymptote once we've shifted this. Okay, so we're going negative, this point shift from 0 to negative pi halves, and then going down 1, 2, right, everybody? So we're landing right there. This one that was at pi fourths shifted back to negative pi fourths, which is right there, and down 1, 2, right? Okay, it was right here. It's really hard to draw it in. And then this was at pi halves, right? We shifted back to 0, back pi halves. So we're at 0 and shifted. See, I didn't draw it to scale, and it's really messy. And down 1, 2 would put us down here. That one should be on 0. See, I just didn't draw it to scale. This is the worst example to do first because it's really hard. And then we're shifting this back from 3 pi fourths back to pi and down 1, 2. So we're having this starting to look like this. So do you see how you'll just keep shifting them back? So then you can, from there, just kind of shifted them back pi halves. But this was like a really advanced one. I should have started with one more basic because there's just a lot of points in here. Yes.
Does it like have to be dead on accurate?
No, really it doesn't have to be dead on accurate, but this just gives us an idea of like where they're going to land exactly if you had to be accurate. You know what I mean? So it's really hard to freehand them. That's why I hate these ones. And they're I'm like, so just do your best. Just do your best. That's all I care about. So maybe I'll just do one off the worksheet and then just let you practice. Number 15. Does that sound like a deal?
Yep.
Okay. So number 15. So first of all, our amplitude is at 3. So our amplitude's at 3. The number of cycles is multiplied in front. So there's a 1. So we're only drawing, this is a way better example because there's only one cycle. So one cycle from 0 to 2 pi. Then we're shifting right pi fourths. And then up 2. Okay. So 1, 2, 3. 1, 2, 3. And it's really hard. It was way easier for me to draw on my paper. It's really hard to draw to scale on this huge thing than if you want this. So our original function, it is a sine function. So it starts right here in the middle. We bounce all the way to the top, bottom, back up. And that would be 2 pi. Okay, so now we don't need a whole lot of stopping points. We need this one, which will be pi, right? And halfway between there would be pi halves. And then that's 1 pi halves, 2 pi halves, this will be 3 pi halves. That's good enough. So does everybody see my dots? Is everybody comfortable? That's just the original. Now we're going to shift them all up 2 units. So I'm going to make sure I try to draw a little bit more to scale. So we're going to be going up 2. So up 2 units. So up from here and then right pi fourths. So so because it's going pi fourths, I'm going to put these in pi fourths because then it's really quick and easy. Do you see what I'm saying? So isn't it halfway between pi fourths? So this is 1 pi fourths, 2 pi fourths, this is 3 pi fourths, this is 4 pi fourths, this is 5 pi fourths, so this one's not too bad. This is 6 pi fourths and 7 pi fourths. And that is 8 pi fourths. Okay, so now it'll be pretty easy. We're at 0, right? We're going right pi fourths, so we're going right to pi fourths and up 1, 2. That point now becomes that. This point, we're going right pi fourths. So you could, if you wanted to be exact, you could say I'm taking pi halves plus pi fourths, right? We're adding pi fourths, which is 3 pi fourths, isn't it? You could take your calculator, 1/2 plus 1/2 plus 1/4. You get 3/4, so that's 3 pi fourths. So we're at pi halves, we're then going to 3 pi fourths and up 1, 2. Do you see how I'm finding out exactly where they go? Just because it's easier for me to graph it that way. I think it's easier than guessing. So then this was at, but we haven't cut in pi fourths. So this is at pi, we're going to add a fourth of pi fourths and then go up 1, 2. So it's going to be right there. And then this one's at 3 pi fourths, we're going to add pi fourths and then go up 1, 2. And then right pi fourths. So that'll be 7 pi fourths, 8 pi fourths, this will be 9 pi fourths. Going right pi fourths up 1, 2. And now we have our shifted sine function. So yeah, you can see how hideous it is and that it is kind of hard to make them perfect. Okay. Do you feel somewhat comfortable to make a rough, the best sketch you can? That's all I care about, is it's the best you can do.
Yep.
Okay. They're kind of hard just because they get messy. If they weren't so messy, but they are. All right, so do 15 through 20. Ready, set, go. And say, write an equation from, so the purple one's the parent function. So let's all just look at this, and then maybe we'll just move on, and I'll take what you've got. Let's look up here, though. So let's go kind of backwards. So if this is the parent function, and then the red function's the shifted function, write the equation of the new function. So first of all, we need to know amplitude, right? Is my amplitude different from purple to red? No, so what's my amplitude on purple?
1.
1, right? So we still have a 1 in front of ours. Is it a sine or cosine function? Sine. So we're going to have 1 sine of, now how many cycles was between 0 to 2 pi? Just 1, right? Right? So we could write a 1 if we needed to, but let's just not write anything. And then what's my shift from the parent function to the, what's my shift left and right? So I like to look at 1 point. Like this one's 0, right? Where is it at now? Pi half. So we went right pi half. So wouldn't that be x minus pi halves? Right? In parentheses. And then you could check a couple more. We were at pi, and then we were at pi, or like we were here, and we're now at this. So do you see how all of them are shifted pi halves? Okay. Then, did we shift up? Yes, right? So we were at 0, right? And we went up 1, 2, right?
Yeah.
Over, right? So we went up 2. So we shifted all of them up 2. Because that's a lot, that's more what you'd see on an end level. That's what you'll see on our test. It's just too hard to draw it in and not get messy. Is everybody okay with that? If you understand that, let's just move on, because really it's more important that you understand something like this. Okay. So stop where you are on problems 15 through 20. If you got a good attempt on most of those, I'll give you points. Okay, moving on. So number 21, it says write an equation for each translation. So we're given y is equal to sine of x, we're going 2 units down. So we'd write it as y is equal to sine of x, and then we'd make sure to not put that in parentheses with x, but go minus 2, right? That's our shift up and down, added on the outside. So there it is, right? All right, so what if I changed it real quick and said triple the amplitude? What would I have put right here? 3, because 1 times 3 is 3. Okay, good. Is everybody kind of comfortable with how to write these? So what if I said in shift, right 2 units? Then we would have done x minus 2 in parentheses, right? Okay. All right, so finish up 21 through 26, and that's all we're going to do on this worksheet. Up to 26.
27 through 30 discussed.
Yeah, we're just skipping those.